142, and 142 divided by 2, divided by 179 will give you 0.7933. Okay, so again, that's your answer. It should be 0.7933, and again, 0.793 is fine. I think on your homework on Connect Math, they asked for 4 decimal. So again, the answer for H here is wrong. I think I look at something else. I think originally I put 500 or less, and then I like, oh, let me do it on more, and then I forgot to change it. But again, everybody see the answer is 0.7933. Question with this conditional probability. All right, let's take a look at the multiplication probability. Well, not yet. I have another question. What if, right? Some of you guys asked me last time or yesterday is, do they always give you the information in terms of chart, right? Do they always give you that information in terms of chart? Not quite, right? Sometimes they give you something like this, and sometimes they give you the percentage, or sometimes they give you the actual probability itself already. But let's say if they give you this problem. In the recent years, in the state of Washington, there were 326,000 high school students. Of this, 159 were girl and 167 were boy. Among the girl, 7,800 dropped out of school. Among the boy, 10,300 dropped out of school. One student is chosen at random. Now they ask you this question. Excuse me. A student is chosen at random. What is the probability that a student is a male? So again, male is looking at this thing here. Do you agree that this is a simple probability? Just a simple probability in terms that, again, we just basically, what is the probability of a male, right? If you go in here, 326,000 students, what's the probability of you select one student and that student is a male? So looking at this thing here, very easy. Hopefully you guys say, oh, this is easy. All I need to do is take off the boy and divide by the total, which is, that's what you have, which is the boy is 167,000 divided by 326,000, right? Which is, again, 0.5123, which is, as you can see, this is your simple probability. How simple? Only one item, which is the male, right? And again, what is the probability of the student that drop out? Which is, again, if they drop out, remember, drop out, you have to take the female drop out and the male drop out, right? The girl drop out and the boy drop out, which is to find the probability of drop out, which is, again, we have to take the 7,800 divide by, add it to 10,300 and divide by the total of the student, right? Which is, again, 18,100 divided by that will give you 0.0555, right? And here come the other item, which is, again, what's the probability of that a student is a male and dropout, right? So again, what is the male and dropout? Look at this thing here. I picked one student. What is again, looking at this thing here, we're not worried about a female dropout. We're not worried about the other male who are not dropout. We specifically just want the male who are dropping out, right? Which is, again, looking at this thing here, do you agree that the male dropout is 10,300 out of 326,000, which is, this is what we have, okay? So this thing, this three item is in your previous problem. In your previous problem, in your previous section, which is 4.2, right? So now they give you this thing here, which is, again, D, which is, this is where 4.3 start, right? Given, if you read this and you say, oh, given, that's a conditional probability. That's what we have. Given the student is a male, what is the probability that he is dropping out of school? right? So given is a male, meaning now, do we looking at the 326,000 as a whole? Hopefully you say no, right? Because it's the word given, meaning some condition have to met. Some condition have to met, which is again, we need to take the condition, which is the male, right? So looking at this thing here, do you agree that there are 167 male, right? And out of 167, only 10,300 dropping out, right? Which is again, everybody see that again, given that is a male, which is again, that's your condition is given is a male, what is the probability of that he dropping out, right? Which is again, 10,300 divided by 167,000, right? Which give me that. Now, whoever have a calculator, if you have a calculator, if you take this number, it's very close, it's probably will not be, if you take this number 0.0316 and divide it by 0.5123. If you take those two numbers, if you take 0.0316 divided by 0.5123, do you see that that number is very close, or is basically exactly, if you round it up, is exactly 0.0615 or 17, right? So again, this thing here just to show you, that if you use in the formula, right? If you use in the formula, and this is what they ask you, or this is what they the reason why they give you this question this way is, again, how did I find the answer D? Well, all I need to do is take the C, which is where they join, the N portion, divided by the A, which is the male portion here, which is again. And if you look well, I don't think I have an E. Is that, yeah, that's an E. So if you look at this thing here, if you look at the E, which is again, you can do it both ways. You can look at your data, or you can use what you have, right? You can use what you have, which is again, what is the dropout? Well, the dropout is your new, given the student is dropout, which is, that's your new denominator, right? Your dropout, which is again, if you were to use your information, what is my new total? My new total is, I need to take the 7,800 plus the 10,300. That's my new total, right? My new total is 18,100, and then divide, or not divide, but again, given that the student dropout, which is the total is 18,100, what is the probability of the student is a male? Well, the male student in the dropout category is 10,300. So again, if you take this thing here, which is again, same thing go. If you take 0.0316, that's the N portion, divided by the dropout, which is the 0.0555, you will get this number. Okay. So again, divide this. You take the yeah, that's correct. Question with this. Question with this two item, and again, you can using your data, dissect your data, and one thing is, sometime on Connect Math, instead of give you the actual data, they give you the probability. They say that the probability of A is this, the probability of B is this, the probability of A and B is this. What is the probability of A given B or B given A? Okay, so again, sometimes they give you the probability. You don't have to find you have to use the probability. Use what they give you to find the answer. Question with this conditional probability here. Now, if you don't have question with conditional probability, let's take a look at the multiplication rule. So this is the last item. Well, there's one item after this, but again, the multiplication rule, which is, as I mentioned, conditional probability is one entity and multiplication rule is another one. It's a two separate kind of, they force us together, as you can see here. Looking at this thing here, which is like I mentioned, one thing is, reminder last time, last time or 4.2 or what the problem we've been doing when I say the word and earlier is we select one item. What is the probability of this and that? Meaning, what is the probability of the one item that you pick out fit the description, right? You know, is, you know, in the sense of that. Now, the multiplication rule, they have the word and again, but in 4.3, when you select multiple times, when you do multiple item, this and is tell you to multiply. Okay, so this is what they have is probability of A and B is equal to probability of A multiplied to probability of B given A is already taken out. Okay, so again, looking at this thing here, as you can see, the second part, this is your conditional probability, right? Probability of B given A, right? So basically, something happened, right? Something happened. You perform the first item, probability of A, and then you go in and you perform the probability of B. Okay, so imagine this. Let's say if I have something like this, and this is the easy example here, right? As you can see, if you look at what I have, hopefully, let me see if you guys can see. If you look at what I have, well, hopefully it's blinking. All right, so everybody see that in my hand, I have, imagine that this 2 blue pen and this 3 black pen, right? So looking at this thing here, last time I asked you is if I go in and select one pen, if I go in and select one pen, right? What is the probability of me select one pen and that pen is blue and, well, I don't have a pencil, so I need a pencil to have a different category, right? For instance, now, you know, if I select one, last time, if I select one, what's the probability of that pen is a pen and blue, right? So again, that's one item fit both description. But now this thing here is you go in and you select 2 items, okay? You select one and then you select another one, okay? So now in this multiplication rule is you do multiple times, and that's why you select multiple items. So this is what we have is we go in, we select one pen, and then we go in and we select another one, okay? And because that's why there is some condition need to be met, right? Some condition need to be met in the sense that, again, this thing here, this thing already happened. Now we have to find the next one, right? Which is a condition of B given A already occurred, okay? So, and again, A and B, they can be interchangeable. So here come a new definition, or here come the thing that you want to looking for is, one thing you're looking for is, well, whenever we deal with the word and, or whenever we do multiple time, whenever we do multiple time, is the 2 event independent or do a 2 event is dependent? Okay, so again, prior to this, we have mutually exclusive and not mutually exclusive. And then we have a conditional probability. Now we have an independent and dependent. Okay, so how can the 2 events are independent? Basically, if the 2 events does not affect each other, then they are independent events. Okay, meaning again, looking at this thing here, if they are independent events, meaning, think about this thing here. If I have a coin and I flip the coin 2 times, right? If I flip the coin 2 times, is the 2 event, the first event is I flip the coin the first time. The second event is I flip the coin the second time. Let me ask you, is the 2 events, are they independent from each other? Meaning, does the outcome of the second one affected by the outcome of the first one? Hopefully you say it's no, right? Because every time you flip the coin, do you agree that you flip the coin every time it's 50-50, right? Either head or a tail, right? And you flip the second time, it's still a head or a tail, right? So, or in the sense, or if you want to remember the dice we have yesterday, if I roll the dice, my event is I roll the dice. My second event is I flip the coin. Do you agree that the two events are independent from each other? Meaning roll the dice does not affect the outcome of the coin, vice versa, flip the coin does not affect the outcome of rolling that dice, right? Because they doesn't affect each other. So if you have that, if you see that they are independent, then again, the conditional probability will be the same as the second item, because again, every time you do it, it's the same. They tell you that if you see that they are independent, all you need to do is take the two probability and multiply them. So if the question I ask you, if I roll the dice, what is the probability of me roll the die and land on number 1, and then flip the coin and it's land on a tail, right? So what would be that probability? Well, the probability of me roll the dice and land on number 1 is I have number 1 over 6-sided dice, right? 1 over 6. What is the probability of me flip the coin and land on a tail, which is I have 1 tail out of 2-sided, which is 1/2. So all you need to do is take 1/12, multiply to 1/2. I mean, not 1/12, 1/6, multiply to 1/2 to give you 1/12. Okay, so that's what multiplication rule is. Basically, if it's independent, you just take the probability and you multiply each other. If they don't give you a fraction, if they say the probability of this is 0.25 and the probability of another one is 0.3 and they are independent, you just take 0.25 times 0.3. Okay, so but now let's take a look at this problem here, which is, again, you probably say, you know, I did not type that other item up, but hopefully you guys can visualize that you flip the coin and you roll the dice. The two item does not affect each other. Assume that the two things does not touch each other, right? You can argue that, well, I do it and they touch each other. But again, assume that the two item does not touch each other. You roll the dice and you flip the coin. It does not change the result or the outcome of one another. But let's take a look at this thing here. And again, I think this is your typical problem that you have. And this is what we have is a storage have 10 computer. And out of that 10 computer, they contain 3 are defected, meaning 3 of them are not working properly, right? We don't know which 3. We know that there are 3 in there that is not working out of the 10, right? 2 computer, as you can see, that's the difference between this and the other one. The other one was 1 student, 1 store, 1, 1, 1. We select only one thing, right? But this one here, 2 computer are draw as a random and test, right? We take 2 computer and we test. So this is what they tell you is let A be an event that the first computer is draw. You go in the first time, you take out 1 computer. And let B, the B is you go in the second time, you take out a second computer. And you want to see if they are, you want to test to see if they are defective. So everybody see the story or the information they give us. In this room, in this storage room, we know that there are 10 computers. Out of the 10, 3 of them are broken. We go one at a time, which is A, we go in and select the first item, and B, we go in and we select the second item, okay? So looking at this thing here, they ask you find the probability of A. Find the probability of A. So what is the probability of A? Well, probability of A, if I go in the first time, how many computer is defected? Do you agree that there are 3 defected computer out of 10? Which is, do you agree that the probability of me going the first time, I you know, let's imagine that this storage doesn't have any light. I just go in there blindly and take out 1 computer. The chances of me taking out a computer and that computer is broken or defected is 3 out of 10. That's the simple event, right? And now you have to know what this symbol means, right? This symbol meaning, again, find the probability of B given that A have already occurred. Meaning A, you take the computer out, you put it on the side, you test it, and that computer is defected. Now you go in the second time and you select a second computer. What will be the probability of B given that A have already happened? Now, if A has already happened, do you agree that now, do I still have 10 computers in my storage? Do you agree that I no longer have 10 computers in my storage, right? Some condition, what is the condition? The condition is you go in, you take out 1 computer and that computer is defective. That's what the condition is, right? I took out one, I tested, one is gone. Meaning now I go back to the storage, I only have 9 computers left. And out of that 9 computers, I only have 2 because one of them, the defective one, I tested already. My A item, I tested out already.
But wouldn't the defective, wouldn't you, when you take, what you're saying is 9, why isn't it 7? Because you took 3 already out of
No. We don't know which 3. The question, the problem is this. In this storage room, there are 10 computers. And we know, somehow, we know some report that out of that 10 computers, 3 of them is defective. We don't know which one.
Okay, so you start off from 10 again?
Yeah, we still have 10 in the storage, right? So the problem is this, right? We have 10 computers originally, and that's the 10 computer. We always have that 10 computer. We know that 3 of them is defective. We don't know which one. Just, you know, or imagine this, you know, imagine that you have 10 computer and 3 of them marked red. 3 of them, the 10 of them, right? But 3 of the 10 is the color is red. Okay. But now you go into this storage and there's no light, it's total darkness. You randomly just pick up one computer. You still with me here?
Yeah.
So the question is, what is the probability of you pick for part A? What's the probability of you pick out a computer and that computer is red? So again, it's total darkness. You go and you blindly pick out one computer. What's the probability of that computer is red? Which is, again, there are 3 red computers out of 10.
Okay, I understand A, but B. So okay. B isn't to A.
Now, once you have that, you got the red computer outside. How many computers still in the storage?
So you just take one computer out of the first?
Right.
So
for part A, they say A is you select one computer, right? Which is you take out one computer. Do you agree that now there are still 9 computers in that storage?
Okay.
Right? And it's still total darkness, right? You go back in the second time. That's what B is. For B is they basically tell you that you go in the second time, given meaning you took out one already. Given A is already occurred, meaning you took out one already.
Okay.
Meaning so now you go back, which is now in that room, you only have 9 computers, and out of that 9, there's 2 red color, right? The 2 defective one.
Okay, thank you.
Is that making sense?
Yeah.
Okay, so it's not the 10 minus 3. We don't know which 3. We don't know which 3 is broken, which 3 is which 7. Yes, there are 7 good and there are 3 bad, but we don't know which one. So we cannot assume that this 7 is good and this 3 is bad. Okay, so that's the idea. Okay, so now you probably say, wait a minute, Mr. Tran, part C is very similar to what we've been doing earlier in terms that probability of A and B, right? Probability of event A and event B. But because, again, one thing is because of this 2 computer, because you select 2 computer, because you select multiple times, this is tell you that you need to multiply. If they tell you that you go in and select 1 computer, then it's basically what is the intersection, what is the item fit the description, okay? Which is in this case, everybody see that, again, go back to our formula. Our formula tell us that to find the probability of A and B, all we need to do is find the probability of A, multiply to probability of B, given that A is already taken out. And again, hopefully you guys recognize that, hey, we got probability of A. What is probability of A? Probability of A is 0.3. Wait a minute, we have probability of B given A, which is, do you agree that this is my probability of B given A, which is 0.2222. And to do this problem, all I do is I take the first item, multiply the second item, which is, again, 0.066, I think it's like 0.06666, which is 0.0667. Okay, so again, all they did was, again, as you can see, hopefully you recognize that they kind of lead you part A, part B, so that you can answer part C. Question?
Mr. Tran, I have a question.
Yes.
So you're always gonna minus when it says you have defective. To find the A, you always gonna, well, you'll divide it first, and then for the B, you always take.
Because A is already happened, just like a pencil, like I mentioned, or the pen I asked you guys last time, right? Let's say I have 5 pens on my hand, in my hand, right? If I took out one and I don't put it back, I just took it out. Do you see that once I took, the first time I have is, again, I have 5. I took out one, now I only have 4, right? So because of the conditional probability, they assume, again, for part B, the reason why we have 9 is we assume that A have already occurred. That's what conditional probability is. A is already happened, and what is A? Well, A is you take out one item, and that's why you subtract to give you one less. Is that making sense?
So when you say you're going to take one out, you're talking about in part B. Because
yes. Well,
in part A, we divided 3 divided by 10.
In part A, if you look at this thing here, if you look at, let's take a look at this thing. If you look at this item right here, this is what we looking at right here, ladies and gentlemen, right? Let's take a look at, let me highlight in red. So again, if you look at this event, if you look at the thing that I highlight in red, right? Let A be the event that is the first computer is drawn. What does that mean? The first computer draw, meaning basically, again, what is the probability of you select one computer and that computer is defective? That's what event A is. That's what the question is, right?
Mm-hmm.
So again, so how do we find the probability of defective item? Well, what are we looking for? We're looking for the defective item. How many defective do we have? Well, we have 3, right? That's where my 3 come from. Out of what is the total, which is the total is 10. So that's why we have 3 divided by 10, because what we're looking for the defective out of the total, which is 10. Okay. And for B, they tell you that you go in the second time, right? So A have happened. A is happened already. It's done, right? Now for part B is they say now you go back the second time. And because you go back the second time, but A, they did not say, oh, put it back, right? They did not say, take the computer and then put it back, right? You defeat the purpose because you try to see which one is defective, right? So A is already happened, is already occurred, meaning one of them is gone. Now you go back the second time. That's why you have to subtract 1. You have to deduct 1.
From the total amount.
From the total amount, and
Okay.
also from the total defective.
Okay.
Because we assume that we got one of the defective out.
And do we always do that for finding B divided by A for part B? Always
Yes.
take one out?
Yes. If they are dependent.
Okay.
If they are dependent, yes, you have to deduct them out. And again, part C is basically just multiply them. And again, are A and B, are they independent? As you can see, they are not independent. Why they are not independent? Because as you can see, as I will mention, the probability change it, right? The first one and the second one, they change it. And because